And welcome back to Pre-Calculus. I know you all were wondering what you missed today when you weren't in class at a leadership forum or whatever, and I want to tell you that we decided we were going to go back in time and we were just going to learn long division today in class. So, no, I'm sorry, no, that's not the case. Yeah, I know, I'm so mean. Today we're going to do multiple angle identities, and these are used in calculus, so it is something useful to use. You're going to get problems in calculus where you're not going to be able to solve them unless you can convert them to easier problems, so this is going to give you the tools you need. And second part is it's an easy build on what we learned yesterday and the day before. If you recall, yesterday we learned a formula for finding the sine of u plus v, and also cosine u plus v. And sine u plus v, the formula is you take the sine of u, multiply it times the cosine of v. If you're adding, you still add, and this time you say the sine of v cosine u. And that's the formula for addition. We're going to make it easier today. What if u and v are exactly the same number? So what we're dealing with is, what do you have if you've got sine of 2 times u, which can be written as sine of u plus u. And you're going to find that the formula simplifies a little bit, and it's, like I said, it's going to be useful when we get to calculus. Because what happens is, the same formula applies, but all of the u's, or all of the v's, if you will, turn into u's. Boom. Boom. Well, v's gone. It's now u plus u instead of u plus v. So instead of a v, we've got a u everywhere. And now if you look at it, it's even easier, because if you have sine u, cosine u, sine u, cosine u, and you've got 2 of them, that's the formula. No, not squared. There's not multiplied. It's just 2 sine u, cosine u. Much easier formula. Yeah, it's a little bit easier. So let's just try one to see that it really works. Yeah, no, I'm not going to erase that. I'm actually going to just take out the calculator. Pick your favorite number between 42. So 2 times 42 would be 84. So I'm going to verify this formula just with an example. So we'll just take the sine of 42 degrees, multiply it times the cosine of 42 degrees, double it, and see that we really get the sine of 84 degrees, because that's what the formula says. So pull out the calculator, clear everything off. First, let's just check what the sine of 84 is. Wow, it's a big number. It's almost 1, and that kind of makes sense because 90 degrees is 1. 1. Well, it's kind of impressive. You know, right. And actually, it's like you're near the top of the Ferris wheel. You're pretty much at the top. Now, what is 2 sine 42 cosine 42 equal? Oops, let's try the right number. 42.
Same thing.
It works. Yes. Yes. Yes, it works. All right, I did save the more interesting one for second. What about cosine 2u? And this one's interesting because it looks like a formula we've already seen, and it's going to be useful for power reduction. And it's always good when you can reduce powers. Right. Okay. So cosine 2u is the same as cosine u plus u. And so we'll just go back to the regular formula for when you add 2 numbers together in cosine. Oh, no problem. I will pause. Okay. All right, we won't ask Mary what her mail was. All right. So this formula says when you're adding, you've got cosine u times cosine u. This formula, though, the addition property for cosine reverses the sign. So this plus becomes a minus. Sine u, sine u. Remember, the v's gone away because it is just u again. So it's a simpler formula. Well, cosine u times cosine u is... No, this time you can say squared. Yeah, it's cosine squared u minus sine squared u. It looks like the Pythagorean theorem. If it had been cosine squared plus sine squared, it would have worked perfectly, but it's not. It's cosine squared minus sine squared u. And that's the formula for cosine 2u. Now, I'm going to put some variations of this formula that you're going to use more times than not in calculus than this one, because the problem with this equation, it involves two trigonometric expressions, cosine and sine, and we want to get rid of one of those, and we will use the Pythagorean theorem for trig that says cosine squared u plus sine squared u equals 1. Or if I rewrite this, cosine squared u equals 1 minus sine squared u, and sine squared u equals 1 minus cosine squared u. Okay. No, I'm going to use the Pythagorean theorem identities to substitute in and get rid of one of these two terms. So the first time, I'm going to replace cosine squared with 1 minus sine squared u. And I'm just going to plug it in for cosine squared and see what we get. Well, okay, the reason I'm doing this is I've got cosine squared and sine squared. And we don't want both. We'd like to just get rid of them and just have one of them. Okay? So I'm going to replace cosine squared with 1 minus sine squared u. It comes right out of the Pythagorean theorem identity of cosine squared plus sine squared equals 1. Now, it may not look easier, but it really will be. When I put that in for cosine squared u, I get that cosine 2u, sounds like a Valentine's or happy birthday. Cosine 2u, cosine, yeah, no. Okay, is equal to 1 minus, yeah, it's late in the day, 1 minus sine squared u, that's from the substitution, minus another sine squared u, or the second formula is that we could say, here's the first one, and the second one is, we could write it as cosine 2u equals 1 minus 2 sine squared 2u, no, just 1u, right. So at least now we can express it as just using sine. I will leave it to you all to see that this also works. If you want, you could write it again just using cosine, replacing sine squared with this, and you get 2 cosine squared u minus 1. The 1 and the 2, both of those work. Here, I'll pause this first. All right. So we end up with these three equations for cosine 2u. They're all the same thing. It's just one is expressed in terms of sine squared, one is expressed in terms of cosine and squared, and the other uses both. Now, it's sort of like when you're making cat's cradle and you go on to make Jacob's ladder. It's sort of like we just made cat's cradle, and we're going to go on to take it one step further and make Jacob's ladder out of this.
We're doing this play right
So, somebody noticed in calculus, there are times when you have to do tasks in calculus and you're given sine squared and cosine squared. And it turns out those are very difficult to work with, but it turns out the cosine 2u is very easy to work with. So it'd be nice if you could take squareds and turn them into unsquared, if you will. They call that reducing the power, or what do they call it in the book? Yeah, reducing in power. All right. So we can rewrite this formula in these two formulas right here and right here in terms of sine squared to get what is called a power reduction formula. So I'll derive them for you, but you only have to put down the final result in your notes. So if we start with the first one, if I subtract 1 from both sides, no, actually, you know what? It's going to be easier. Yeah, I'll just go ahead and subtract 1 from both sides. I'll end up with negative 2 sine squared u minus 1. I'm just taking this formula and subtracting 1 from both sides. Equals cosine 2u minus 1. Right. Now I divide both sides by negative 2. And I get the formula that sine squared u can be reduced down to. Now I'm going to do some adjustments with the negative. Negative by negative is a positive. All I'm doing is reversing the numerator so that I get rid of the negative sign all over 2. So anytime you see sine squared u in a problem, you can replace it with 1 minus cosine 2u over 2. That's the power reduction formula for sine squared. Yep. The other one's easier to see. I'll just write down the answer. Turns out cosine squared u, if you end up with cosine squared u, you add 1 to both sides. It is cosine 2u plus 1. I swear I'm going to think of happy birthday now every time I say cosine 2u. Yeah, exactly.
That is just like simple algebra.
Yeah, these just come out of algebra. Exactly. And hopefully I wrote them all down right. Yeah, you know, it's cosine 2u plus 1 or 1 plus cosine 2u over 2.
Cosine 2u plus cosine 2. I'm sure your voice sounds so beautiful being recorded right now.
And so actually that is enough for the recording for today. I don't want to record too much. We're just going to work some problems with that in class. So